Good day, students. Today I am going to explain regarding the applications of nanostructures. Okay, applications of nanostructures or nanoparticles. In this, we have this is the fourth unit. Okay, right? Already we discussed regarding the first unit, second unit, and third units. Today we are going to discuss regarding the fourth unit here. Okay, in fourth unit, applications of nanoparticles. In that, first we have by using quantum dots, nanowires, and thin films. Okay, why where we use nothing but what here we use quantum dots, nanowires, and thin films in LED and solar cells. Okay, so LED using quantum dots and nanowires and thin films. So we will explain this concept here. What is LED? First of all, light emitting diode. Okay, what is light emitting diode here? It is a semiconductor device that emits visible light when an electric current passing through it. It works in the principle of electroluminescence. Okay, what is electroluminescence? Luminescence is the meaning nothing but what? Illuminate, nothing but what? Lightning. What we can say, emit light. Okay, the substance which having the nature of emitting light, nothing but what? Luminescence, electroluminescence. See here, in this light emitting diode, okay, semiconductor diode, we use quantum dots here. Okay, we use what? Quantum dots, right? Quantum dots, we use quantum dots. See how we use quantum dots here. See this whatever the nano material, okay, which is in the quantum dot size, that should be what we can say, sandwich between the two layers here, two layers of PN junction diode. One is P type, the other is N type. In between this layer, okay, we use what? Quantum dots here, quantum dots. So when we connect this P type and N type to a battery, the flow of current passes through the nano dots. Okay, that due to that whatever the flow of current. See, I am explaining briefly here, right? I am explaining briefly because we have less time. See, the here in forward bias PN junction, as the electron cross the N region and recombine with holes in the P region, the electron dissipate, radiate, recombine with the holes in the P region. So this is what all the theory. Just you go through this theory. Okay, I am giving rough explanation here. See, whatever the quantum dots, that material is placed in between PN junction. Okay, so the due to after applying this to the battery, what happens? The current flow through the what? Quantum dots, that is nanomaterial. Okay, nanomaterial here. So nanomaterial here, what happens actually? What happens actually here in LED? If the semiconductor is transparent, see what happens actually in LED? The quantum dots. So the electrons in the quantum dots will be goes to excited state and will comes to ground state, because when the size decreases, what happens? Energy gap will be increased. Okay, as the quantum dot size reduces, its color also reduces, changes, sorry, it will converts from red to blue. Okay, when we decrease the size of the quantum dots, so energy gap will be increased, and the radiant energy coming from the, when electron jumps from higher energy level to lower energy level, okay, what happens? It will emit some light, nothing but what? Some color. Okay, actually these light emitting diodes are what? Monochromatic sources. They will emit particular color of light. Okay, so like that we can explain the light emitting diode. Here quantum dots are used in LEDs. Even though nanowires and thin films also used in the LED. Okay, light emitting diode. See, already we will see in railway stations the displays. Okay, they are made up of LEDs, right? So these are what this is what about how the quantum dots are used in LED. Simple principle: quantum confinement. Okay, excitation of electron, and when it comes to ground state, it will emit some photon here. Okay, of particular wavelength, nothing but what? Particular color. Like that, it will emit what? Light. Okay, so this is what LED, where we use what? Quantum dots here. Okay, next LED using quantum dots. First there are LCD TVs and LCD TVs. Okay, then after we are getting, see in the market we have now LED TVs also. Okay, where we use quantum dot. Okay, in LED display device, quantum dots. Okay, semiconductor nanocrystals which can produce pure monochromatic red green light. Okay, quantum dots naturally produce what? Monochromatic light. So like that, they will produce what? These colors, and they will behave like what? LEDs, light emitting diodes. Okay, so quantum dots we use in LEDs, right? Next, advantage of quantum LED: cost effective. Okay, much more brightness, more efficient, as well as more stable devices. Okay, and made up of environmentally suitable materials. That is the reason, okay, we use what? We will develop this, what we can say, quantum LED in lightning industry, right? So this is about what? Quantum dots in LEDs. Now LED using nanowires. Okay, nanowire based LED are constructed in core shell configuration. Core shell configuration have an inner core structure and outer shell made up of different components. The inner core is made up of gallium nitrogen, and the outer shell is made up of indium gallium nitrate. Indium gallium nitrate. The light is in such a diode is independent on the light in such a diode is independent on the mechanical strain that exists between the two materials. The mechanical strain depend how the two layers are in contact. Okay, so component, see here, in contact. So the two layers are in contact with each other. The number of nanowires in LEDs can be examined using nanoscale X-ray microscopy in the electron synchrotron. The method is usually very time consuming. If the nanowires are slightly bent or there are defects in the structure, then the LED does not function. Okay, so So this whatever the nanowires we use in the light emitting diodes. Okay, see they are actually, these are very what we can say, they are very small. The nanowires are very small, about 2 micrometers. Okay, and 10 to 500 nanometers in diameter. Light emitting diodes made from nanowires would use less energy and provide better light. Okay, better light. The nanowires provide more, the nanowires provide better light. The nanowires provide more natural light in LEDs. These LEDs could be used in smartphones, okay, televisions, and in different sectors, okay, in electronics, right? So like this, the nanowires are used in the LED lights. Okay, okay, the main thing is what here, smartphones. In smartphones also we use what? Nanowires. Okay, due to their small in size and having more capacity, they used in what? Smartphones. Next, LED using thin films. Okay, thin films also used in LEDs. Okay, these thin films are we developed by using what? Vapor deposition method. Already we use bottom up approach. By using bottom up approach we develop these thin films. Okay, so the thin films are also used in LEDs. Okay, the market of high brightness light emitting diodes, LEDs, is growing rapidly, but market penetration is being slowed. Okay, somewhat by the high price of retrofit LED lamps. On reason for this high price is the drop in efficiency of LEDs at high current densities, which increases the number of LED chips. Okay, so it is all about what? There is some theory. Okay, just make some important points from these notes. Okay, don't write all the things ఓకే, వాట్ ఎవర్ ద సెండెడ్ మెటీరియల్, ఏదైతే మెటీరియల్ పంపించడం జరిగిందో అది యాజ్ ఇట్ ఈస్గా మీరు రాస్తే చాలా ప్రాబ్లం అవుతుంది, లేదంటే చాలా హెవీ అయిపోతుంది. ఓకే, ఓన్లీ ఇంపార్టెంట్ పాయింట్స్ తీసుకోండి, అట్లా మీరు నోట్స్ ప్రిపేర్ చేయండి. ఓకే, టైం తక్కువ ఉంది మనకు, ఓన్లీ ఇంపార్టెంట్ పాయింట్స్ తీసుకోండి. సో ఖచ్చితంగా అప్లికేషన్స్ ఆఫ్ నానో పార్టికల్స్ ఖచ్చితంగా వస్తాయి. ఆ క్వాంటమ్ డాట్స్, నానో వైర్స్ ఎక్కడ యూజ్ చేస్తాం. ఓకే, నెక్స్ట్ మనకు సింగిల్ ఎలక్ట్రాన్ డివైజెస్ ఉన్నాయి, దాంట్లో కూడా మనం ఏందనేది చూస్తాం అన్నట్టు. ఓకే, సో అట్లా క్వాంటమ్ వైర్స్ కానీ తెలిపి నెక్స్ట్ మనకు ఉన్నది అంటే సింగిల్ ఎలక్ట్రాన్ డివైస్. నెక్స్ట్ టాపిక్ వీ హ్యావ్ సింగిల్ ఎలక్ట్రాన్ డివైజెస్. ఓకే, సింగిల్ ఎలక్ట్రాన్ డివైస్ ఆర్ బేస్డ్ ఆన్ ద కంట్రోలబుల్ సింగిల్ ఎలక్ట్రాన్ ట్రాన్స్ఫర్ బిట్వీన్ స్మాల్ కండక్టింగ్ హైలాండ్స్. What is island? Actually it is a nano dot or nano material. Okay, island area is nothing but what, it is a nano material. Okay, it is not ఏదో అనుకోగలరు ఐలాండ్ అంటే, ఇట్ ఈస్ వాట్, నానో మెటీరియల్. ఓకే, సో దిస్ ఈజ్ వాట్ ఐలాండ్ is nothing but what, nano dot or nano material. So here see, island, this method or this devices are in what we can say invented by Millikan. Okay, in 1909, and illustrated the manipulation of single electrons. However, the single electron device cannot be implemented in solid state circuit until late 1980s due to limited fabrication techniques. Basic physics of single electron device: assume a small metal sphere. Okay, I will explain here. See this, whatever the, see here we are using a metal sphere here. This metal sphere is what, it has no charge. Okay, this is called island. Whatever the metal sphere is what, island. If we decrease this size about nanometers, okay, if we decrease the size of this metal sphere about nanometer size, what happens? See, and decrease that size. See, bring an electron. Already I explained what we can say Coulomb blockade effect. Okay, when an electron brings towards the nano material, because nano material is a low conducting material. Okay, it has high capacity charge, nothing but what, it can take more charge. Okay, so as we bring this electron towards the metal surface of nano material, see here, assume, so here when we bring an electron towards this nano dot. Okay, see actually whatever the, it is whatever the electric field here electric field is inversely proportional to the size of the sphere. Okay, as we decrease the size of the material. Okay, as we decrease the size of the material, right, nothing but what, size of the metal sphere, what happens, the electric field will be increases, and the direction of electric field will be in this direction. Okay, opposite direction. When we bring an electron, okay, when we bring an electron towards this metal sphere, and when we decrease this size of the highland, okay, nothing but what, metal sphere, what happens, the electric field, whatever the electric field is inversely proportional to size of the metal sphere. As we decrease the size towards the nanometers, what happens, the electric field will be increase. Okay, so the basic physics of single electron device is what, this. So here assume a small metal sphere, also called island, with zero net charge. In this state, no electric field occurs beyond the boundary of the island. When an external force F brings a single electron from outside close to the island, an electric field E is generated by the non-zero net charge. The electric field is oppositely proportional to square of the island size. Okay, so it may becomes very strong for nanoscale structures. Okay, like that, this is the basic principle. Okay, so this is the basic principle used in single electron devices. Okay, we will increase the electric field, okay, by decreasing the size of the whatever the what we can say substance, and okay, we bring the electron towards it, and it will hold more electric field. This is the basic principle used in single electron devices. The single electron devices are actually, see here, the single electron devices are, single electron box, single electron transistor, single electron trap. Already I explained in the last class, okay, that is single electron transistor. Okay, by using this single electron transistor, in a small area we can build more number of transistors, okay, in a microchip, right? We know that transistor will work like a switch. Okay, at 1 second we can operate off or on the switches, okay, by using a single electron here. Okay, so it is very powerful device, right, we use here. So like this, the single electron devices will be constructed in the by using the principle, this principle, basic physics of single electron device. So the basic principle is what? The electric field increases as the size of the highland, that is metal sphere, decreases towards nano size. Okay, like it will hold more electric field. This is the basic principle. So by the examples for single electron device are single electron box, single electron transistor, single electron trap. So single electron box, it is like this. Okay, source electrode and a small island, that is a quantum dot we have, so it is gate. So like this, a single electron box, it consists of a small island separated from a large source electrode by tunnel barrier. Gate is another electrode which is used in applying a external electric field on the small island. So don't write all these things, just explain. The examples of single electron device are single electron box, single electron transistor, and also single electron trap. So mainly explain this single electron transistor. A single electron transistor is a sensitive electronic device based on the Coulombic blockade effect. Already I explained this Coulombic blockade effect. Okay, blockade effect is the decrease in electric conductance at small bias voltage of a small electronic device. Okay, a Coulomb blockade. So this is what diagram here. Okay, already we know FET, field effect transistor. In field effect transistors we have source, drain and gate, isn't it? These are what? Two junctions. This is what? Quantum dot here. Okay, nano material. I already said this nanomaterial will be sandwiched between source and the drain, and one end it is connected to the gate here. In between this gate capacitor is there, tunnel junctions. Just learn this diagram, okay, and matter single electron transistor because it is important. So like this single electron devices are, we can explain this. So single electron trap here, learn about this, just 2-3 points. Okay, so I am explaining briefly here because we don't have much time. Next we have carbon based transistors, carbon nanotubes, carbon nanotube based transistor, CNT shortcut. What is carbon nanotube? A carbon nanotube is a tube made up of carbon with diameters typically measured in nanometers. Okay, what are carbon nanotubes? Actually, see, in chemistry we have, what are the allotropes of carbon? Graphite and diamond, and the other allotrope is what? Here, carbon nanotube. Okay, we can say actually this carbon nanotube, we can call it is buckyball. Okay, C60. Okay, carbon C60 అంటే ఇక్కడ 60 కార్బన్స్ అనేవి ఒక గ్రాఫైన్ పేపర్లో మొత్తం ఒక పేపర్ ఒక షీట్ మీద కార్బన్ నానోట్యూబ్ అంటే కార్బన్ C60 అనేవి మొత్తం కూడా మనకేందంటే అంటే విత్ టెట్రా వ్యాలెన్సీ అన్నీ కూడా మనకేందంటే మొత్తం ఒక షీట్ తీసుకుంటే C60 అంటే 60 కార్బన్స్ ఉంటాయి అన్నట్టు. Okay, that sheet is rolled to a single walled or multi walled layers of carbon nanotubes. Okay, so ikkada manaku a carbon nanotube is a tube made up of carbon with diameter typically measured in nanometers diameter gala carbon sheet ni ante graphene sheet ni fold cheyadam valla, by folding the graphene sheet, okay, we will get a carbon tube. Okay, carbon nanotube. So that is we are having two types of carbon nanotubes, that is single walled carbon nanotube and multi walled carbon nanotubes. Okay, so single walled carbon nanotube, it is single walled carbon nanotube. Here single walled carbon nanotubes are special class of carbon materials known as one dimensional materials. They consist of sheets of graphene rolled up to form of hollow tubes with walls 1 atom thick. అంటే here the thickness of the tube is about 1 atom, nothing but 10 power minus 10 meters. That small tubes, they are small tubes. By using these tubes, okay, by using, see, it is single walled and this is multi walled carbon nanotube. Okay, here this is what graphite sheet. By folding this graphite sheet into a tube, okay, we will get a single walled carbon nanotube. So these are multi walled. So carbon nanotube based transistors, by using these tubes we can construct carbon nanotube based transistors. CNT based transistors are the transistors in which carbon nanotubes are used. Carbon nanotube field effect transistor was first demonstrated in 1988. Carbon nanotube FET, see, field effect transistor, carbon nanotube field effect transistor. Already just now we learned regarding the single electron transistor. Now we are learning carbon nanotube field effect transistor. So write generally, listen carefully and write generally whatever these topics. Okay, don't leave any answer in the exam. So the types of CNT FET field effect transistors: CNT FETs, back gate, top gate, wrap around gate. Like that there are types of carbon nanotube field effect transistors. Okay, so this is what one type of transistor where we use carbon nanotube. See here, silicon oxide substrate. On this substrate we are using two metal contacts here, two metal contacts. Okay, in these two metal contacts we are disorderly we are placed this carbon nanotube. This is carbon nanotube here. Okay, this carbon nanotube is placed on the substrate having metal contacts. Okay, here one metal contact will behave like a source, drain, other here back. This is at the back we have gate. You know already field effect transistor, already we learned in basic electronics. Okay, so like this we can construct a carbon nanotube field effect transistor. Okay, so it is very simple. Don't leave these answers. Top gate carbon nanotube, this is what top gate. Here we are in the previous case we use back gate, here top gate. Okay, and in between this we placed what gate, what we can say, in between this we are using what here a carbon nanotube. Okay, so like that we construct, top gate CNTs. Okay, like similarly we have wrap around gates. Okay, this is wrap around gate. Okay, like that there are some different types of carbon nanotubes. So this is what third application. Next we have, similarly next we have, see, okay, I will continue this whatever the video, whatever the class. Okay, next class. Okay, because it is about 22 minutes, right? I will continue the remaining applications, okay, in the next class.